Working on Newtonian physics. So, first of all, what is Newtonian physics? It's all the laws that Newton made. So there's the law of gravitation, which is gravity, and there's the law of inertia, which is an object in motion will stay in motion, and an object in rest will stay in rest, and thus is acted on by an external force. And he also made the second law, which was force equals mass times acceleration. And that's what we're going to be working on today. We make it into Newton's first law. So, first of all, let's work on the formulas. So what are the formulas? So gravity is equal to G force, times mass 1, so the first mass. So let's say we have two masses. They have a gravitational pull between each other. That's why. And if there's only one object and no other objects, there won't be a gravitational pull on that object because there's no other objects that'll pull it. So we have mass 1 times mass 2. It doesn't matter what order you put the masses in, divided by the radius. And let's say it doesn't have to be the radius, it can just be the distance. It's just the distance between each other, but like but for planets, if you had a planet, you would use the radius. If you had a planet orbiting a star. And force equals mass times acceleration, as we said. And I'm not sure the formula for inertia. So let's start on inertia. What is inertia? So inertia is that if something has a greater mass, it's harder to move, and an object that has a lower mass is easier to move. For example, I can easily move my backpack. I can move it easily. But let's try this safe. I can't push the safe because it has a way greater mass. So that's what it is. Like, I couldn't push the safe because it has too big of a mass. And that's what inertia is. So, for example, which one would be easier to move? A car or a house? It would be way easier to move a car because a car has less mass than a house. But still, if you compared a car to like a desk, it would be way easier to move a desk. And the house would be like hundreds of times the mass of the desk. That means it would be hundreds of times the inertia. So let's work on force now. Net force equals mass times acceleration. So if I have 1 kilogram ball and it accelerates, let's say it accelerated when I left my hand. So we have the estimated, I think that was probably like 2 meters per second squared. And so we have force is equal to 2 meters dash seconds times 1 kilogram. So the force is equal to 2 newtons. Force is measured in newtons, named after Isaac Newton, who invented a force. Nobody can invent a force, but he just found out what it is. So, and let's do another problem. Let's say I have this ball on a string here. I'm going to decelerate it about 5 meters per second squared. And this ball is only about 100 grams. So we have force is equal to 100 grams times 5 meters per second squared, and that force is equal to 500 newtons. So that's what force is. And in simpler words, it's a push or a pull. So, because how else do you put a force on something? Like, you can't put a force on something if you're not touching it. Because if you're not, like, I'm not touching my computer, I'm not putting a force on it. So that's why it has to be a push or a pull. A pull is you pull something, or a push is push. So that's what force is. Now let's work on gravitational force. So if I have this ball, that's 1 kilogram, and I have this book that is about 50 grams, and I drop the two, which one is going to have more gravitational force? One of the more gravitational force is going to be this one. So this one has more gravity acting on it than this one. And weight also has to do with gravity. Weight is equal to mass times acceleration of gravity, and acceleration of gravity is equal to 9.98. So let's round that to 10. So let's find the weight of this ball. We have 1 kilogram times 10 would be 10, and this is of course not 10 pounds. This is probably, you can measure it if you want to in kilograms dash AG. Because that's a different form of measurement for weight than pounds. And you can also, for force, 1 Newton. So you can also measure force in pounds. It's not like how heavy something is. It's not that type of pounds, but a different type of pounds. So 1 Newton is equal to 4.4 pounds. Now let's work on Newton's third law. Newton's third law is for every force there is an external force going the other direction. So if I push myself this way, or if I push myself back like this, there's also a force going that way. Imagine you had a boat and you threw something off the back of the boat. That is going to accelerate the boat more because there's an opposite force going the other way. So that's Newton's third law of motion. So that's all of Newton's laws. I think that'll be it for today. Bye. Thank you for watching.